Okay, so these many properties about the covariance is just enough. So let's calculate some covariance, right? So we have learned the covariance, so let's calculate some covariance. So we have this familiar joint probability mass function that belongs to two random variables, x and y. And random variable x can take on three possible values, 1, 2, and 3, and random variable y can take on three possible values, 0, 2, and 4. And both random variables are discrete. In fact, we can understand it because the question says it's a joint probability mass function. Now, these joint probability mass values are tabulated in this table. The question asks me to calculate the covariance of x and y. So, arkadaşlar lütfen dikkat edin. Covariance of x times y değil. Covariance zaten iki tane rastsal değişken arasında tanımlıdır. Dolayısıyla arada bir virgül olması gayet normal. Ona dikkat edelim. Sakın x çarpı y'nin kovaryansını buluyormuşum gibi düşünmeyin. Öyle bir şey yok. X ile y'nin arasındaki kovaryans. Çünkü bu neyin ölçüsü? Bir bağımlılık ölçüsü. Yani birbirlerine olan bağımlılık ilişkilerinin ölçüsü kovaryans. So we are going to use the convenient formulation of covariance, which requires us to calculate the expected value of x times y minus, we also need to calculate the marginal expectations, right? Individual expectations. Now, in order to calculate these marginal expectations that belongs to x and y, we need to determine the marginal probability mass functions, and we know how to do this from last week's course, right? So how do we compute the marginal probability mass functions? The row sum of this table, the row sums of this table gives me the marginal probability mass values for random variable x to take on 1, 2, and 3 values. And according to this marginal probability mass function, the expected value of x is equal to 1.75. And the column sums of this table gives me the marginal probability mass function of y. And with that marginal probability mass function, I can compute the expected value of y as 1.8.